it's Miss Baker. We are going to be doing video lesson for my 8th grade class this time. This is 8th grade LP 35. I know it's backwards again, sorry. But we are doing LP 35 here. Now, last week, LP 34, you were learning how to solve a system of equations by graphing. So we graphed the two lines, one went this way, maybe one went this way, and we looked for the intersection in between. So this week is related, okay? We're going to be using the same basic ideas, the same basic equations, but instead of graphing our line, we are going to use the math steps and the algebra work to be able to find that same point of intersection, but without ever having to use a graph, okay? So it is building on what we did last time. It is also, again, building with Unit 5, remembering that you have to, add numbers to both sides, subtract, multiply, and divide from both sides, keep it balanced, focus on the equal sign, all of those sorts of things, all right? We are going to walk through first the notes page that I have at the front of the packet. Once again, we're solving by substitution. So it says in this packet, number 1, you're going to practice just the substitution property. We've done this earlier, and we're going to go over a couple examples in a few minutes. But that uses the order of operations and PEMDAS. So we are going to have a little review with that. Then, just like with last week, you are going to watch the video and complete the graphic organizer that has your notes on it, okay? I know some of us are having the issues with the links that are in the packets. I don't know what's going on with those. So just make sure that you look in the comment, or excuse me, in the description below, and your link to the video that you need to use will also be there, okay? After you watch the video and complete the graphic organizer, there is a worksheet that has you practice solving a system by using substitutions. We are going to look at independent and dependent variables, which really is just looking at who has the power in this relationship when we're talking about a relationship between X and Y. So which one is the one that is controlling this situation and which one is the one that is following, okay? So we call those independent and dependent, and again, we'll get into that a little bit more. The last thing that you're going to do is work with some word problems here, okay? So we're gonna do solving systems as far as they go in the real world and how we would utilize this and how it is used for real world type problems, including all those super fun word problems. And then at the very bottom, there's a nice reminder of please let me know if you need help. This is algebra, and this is the kind of math that you are going to see over and over and over again. This is the kind of math that is going to haunt you until you are done with math forever. So I really want to make sure that you are able to learn these skills and practice them. I know this is the second or third time we're looking at them this year, but please let me know if you need help so that we can make sure that you are able to understand and really, really be able to utilize these skills. All right, so let's go ahead and take a look at our first learning experience for this week. Okay, so I'm gonna go ahead and share my screen with you guys. We're gonna look at the whiteboard, and on it, we will be doing problem number 9. As you can see on the worksheet, that's titled Substitution Property Practice. This is problem number 9. I've already worked it out for you, but I'm going to walk you through these steps here so you have a good explanation and a better chance to follow along, and hopefully it clears up any issues that may be there. So we are looking at this expression here, okay? It says we're going to take y and we're going to multiply y times 6x minus y plus 2. Now, it also tells us that our x value is going to be -3. What that means is that anywhere the letter x is used, we can replace it with this -3. So we're going to go ahead and take that first step now. I'm going to rewrite this equation, I'm going to rewrite this expression utilizing -3 instead of my x. So that's going to go right here, okay, in the same place that the x was. Now, I'm going to bring down everything else just so you can see how this substitution works and how it looks. So I've got y, I've got my 6. I put this in parentheses, so I've got that negative and I didn't want to get myself confused. So there's my 6, this is the x. I've got minus y plus 2, gonna close that off. Okay, so our first step, we plugged in our x. We're going to do the exact same thing, but now we're going to plug in this y value here. So it says that y equals -6. So now, just like before, I'm going to rewrite this equation, or excuse me, I'm going to rewrite the expression, but I'm going to do it using -6 instead of my y. So in this first chunk here, I've got my y, which is instead -6. Okay. I've also got this y here, which is going to be another -6. And now we're going to bring down everything else. So the -6 times 6. We're going to bring down that extra times -3 here. We're going to bring down the minus, because there is this minus here, and then this was a -6, and I'm going to bring down the +2 at the end. Okay, so now we're going to look at just this part. I'm going to draw a line above it so we don't keep looking back up there. This is what we get. This is what we need to solve. I mentioned earlier we were going to use the order of operations, so I'm going to write that over here just so I can keep track of what's going on. We like to call it PEMDAS. We do our parentheses first. We do our exponents. Remember our little caret symbol. Multiplying and dividing, remember, go together as one step from left to right. And the same is for addition and subtraction. They go together in one step from left to right. So first, let's start inside parentheses. Done. Cool. That's it. We can't do anything in there. So that part is done. We're going to move instead into this chunk of our parentheses, okay? So inside there, I have 6 times -3 minus -6 plus 2. So we have a multiplication, a subtraction, and an addition. And if I look at my handy dandy little rule book here, the multiplication part's going to come first. So let's go ahead and handle this multiplication. A positive times a negative is another negative. 6 times 3, 18. First step is done here, okay? Now we're going to take a look at the remainder of our expression and start working through how we're going to put that together, okay? So looking right here, remember that a minus actually becomes a plus, okay? When you take away the lack of something, right? If you want to take away being hungry, you have to add some food. So we're going to make that a positive, and now you have a 6 here. I'm going to go ahead and bring down the rest of this equation. I got my +2, and I'm going to close off those parentheses. Going to bring down this -6 out front. We're going to continue working inside of these parentheses still, because we're still there. We did that multiplication. Now we're going to do the adding and subtracting in order from left to right. So I have -18 plus 6. If you owed me $18 and you paid me back 6 of those dollars, you would still owe me $12. Okay, after that, we're going to go ahead and bring down the remainder of our problem here. Continue taking our steps a little bit at a time. We've got one more addition to do inside of that. So we're going to go ahead and handle that. If you owed me $12 and you paid me $2, you would still owe me $10. And then we're going to bring down the other side here. I got my -6 times a -10. A negative times a negative becomes our positive, and 6 times 10 gives us 60 for our final answer here. Okay? Now, just to go back and make sure that we have clarified why, because I know I went a little bit fast through these last steps. We cleared through everything in this parenthesis until we got down to this -10. The last step is just to solve whatever it is there, okay? There is another example worked out for you on this page. Feel free to take a look. Remember that you have to go in order of operations, or you will wind up confused on where you're supposed to be going. The biggest thing to remember when you do these, because it trips all of us up, it is my biggest kryptonite when it comes to being able to do math, and I know a lot of people struggle with it as well, is being very careful of our negatives and our positives, okay? Remember in the classroom, I used to have the big number line set up. If you need to make yourself a number line, do it. If you need to use a calculator to help you make sure you get the right answer, do it, okay? I don't want you to lose points or to be frustrated because negatives are hard, okay? They can be very tricky. So make sure that you are being as careful as you can and double check yourselves, okay? That's going to get us through this page for substitution property practice. I will be right back with you in just a few seconds to move on and get us going on the next thing, all right? Okay, so for the next part of your lesson, this is what you're going to be doing. This is where you are going to watch the video. Like I said, look to the description underneath this video. It will have a better video link for you to be able to access your notes page. You are going to be solving a system of equations by substitution. So the same property you just learned, but it's going to help us actually find that point where they intersect, okay? If you look at the top of the page, it says, I can solve a system by substitution. That's our goal. So, vocabulary, it's going to talk about what substitution means. I want you to write a really good definition here for me. Give me at least one real solid sentence that you feel explains what this means, okay? You are going to work on a problem, and again, I apologize, this is backwards, but you are going to work on a problem with the video. The example problem is there. It's going to walk you through the steps, follow along, take really good notes, write everything down. This is a chance for you to get a really good worked out example built. Your next challenge is then you're going to write down the steps that you use. So you're going to make yourself a checklist to use as you go through and solve these problems. That way you have all the steps that you need, and you don't have to keep rewatching a video. You now have the steps and the things that you need to be able to move forward, okay? That's going to be how you do this notes page. Make sure you watch the video carefully. If you need to pause it and replay it, feel free. Take as long as you need to do this. But again, that link will be below this video in the description. Okay, moving on. Now we're going to look at a page for you to practice these skills, okay? As long as you have completed this page and shown me that you tried to learn this lesson, great. I will not be docking points if you make a few mistakes here. This is your practice space. That being said, it is still graded, so please make sure that you do it. Just know that I'm not going to punish you or anything here. This is your practice space, okay? Think of it like a rough draft. So we are going to do the first problem together. I have it worked down on your page, but I'm going to walk you through it and explain the choices that I made and the steps that I took for this. That way you can fully and better understand what we've got going on here. All right, so let's go ahead and share my screen so we can take a look at this whiteboard here. Perfect, so we can see, just like the page set up, we are just doing problem number 1 here. It says you're gonna solve this by substitution. Our final answer, remember, is a point written as an ordered pair. So your final answer must be x, comma, y, all right? Looking at the two equations that they've given us, they tell me first that y is equal to x. So any number I put in for y is exactly the same x. If y is 1, x is 1. If y is 2, x is 2, okay? The second equation they give us to look at says that negative 5x plus 8y is going to equal 15. Our goal is to figure out what x and y value make this statement true, okay? The goal is to substitute things that we know. So let's take a look, and I'll be able to explain a little bit better how this works. So when I say that y is equal to x, that means that anywhere there is the letter y, I can use the letter x instead. So this y right here can be replaced, and we're going to do it. Y and X are exactly equal to each other, so I can replace that with my X, and then I'm going to bring down everything else. So we can look at what we have now. This is an 8 plus, there's the negative 5x here, and it equals 15. Now, you can only substitute things that are exactly equal to each other, okay? Because y and x are exactly equal, I can use those as replacements and substitutions. Now we're going to start using our algebra steps to be able to solve this. So I have negative 5x plus 8x, okay? Remember, for this, we are combining like terms. Negative 5 plus 8, but we keep the variable the same. So if you owed me $5 and you handed me $8, you gave me $3 too much. Now that I've done my math step, I'm going to bring down the 15. Okay, so we replaced our y with our x, we combined like terms, and now this is where we're at. The goal is to get the x alone, because when we say we solve an equation, we are always trying to figure out what that variable is. So we need to get x by itself. That means that this 3 over here has to move away. When a number and a letter are smashed together, remember that that is a type of multiplication. So we're going to do the opposite to cancel. We're going to get rid of this 3. Okay? 3 divided by 3 cancels out with the 1, which means we are just left with our single x. 15 divided by 3 gives us 5. We find out that x equals 5. Okay? We aren't done though, because we have our x, we still need our y. So we're going to go back and we're going to get and figure out what our y is. You can choose either equation for this. I recommend you choose the one that looks easier, okay? Now this is going to be a skill that you will have to hone. You're going to have to improve on it, and it'll get easier the more practice that you get. So when I look at these, this equation looks pretty simple. This equation has a negative in it. It's longer. There's a lot larger numbers. It's pretty easy to see which one's the easier, the simpler equation here. So I'm going to take my y equals x. I'm going to now substitute, because we know what x is. X is 5. So I'm going to say substitute my 5 here. I'm going to bring the rest of this down. Boom. Look at that. Y also equals 5. And now that I have found the point, 5, 5, this is our final answer. That is the point of intersection for these two lines. So if we were to graph them, one of them goes up this way, one of them is going to cross over this way. They are going to meet at 5, 5. Okay? Go ahead, you're going to finish up the remaining problems on those pages. There are 5 for you to practice. Really try your best. And if you need help, please make sure you contact me. I am available from 9 to 3 every day to work with you and make sure that you are able to get this work accomplished, okay? And then we are going to take a look at the next part of this in just a second. So the next part of our packet is called identifying independent and dependent variables. And before we even worry about what those words mean in math, we're going to talk about what they mean in the real world, okay? There was a meme that went around a few years ago, you know, that I am a strong, independent person. There's been songs that have come out recently in the last few years that talk about being independent. So when we think about what these words mean in the real world, it actually makes it easier to understand on math. If I am a strong and independent person, I don't need to rely on others, right? Somebody that is independent is able to manage things on their own generally. They are able to accomplish things pretty much on their own, okay? Right now, you are doing a type of independent studies. You're doing it on your own. You're not working with others really. You are not working in a class. You are independent. Dependent is something we don't say as often, just because independent sounds a lot more fun. But a dependent person is somebody that relies on someone else for something. For example, all of you are dependents because your families have a house. You live in that house. Your families work to get food. You depend on them to bring home food, okay? So you are dependent because you need that extra support, okay? If you are independent, you are 18, 19, 20 years old, you have your own apartment, you buy your own groceries, you pay your own bills, you would then be independent. So when we talk about what these words mean now in math, they are kind of similar, okay? Something that is often independent in math is time. I don't know about you guys. I cannot control time. I can't fast forward, I can't rewind, I can't pause it because I want to see this moment, you know. Time happens and we're kind of along for the ride. Time is generally considered independent. Let's take a look at some of the examples on the page so we can look a little bit more deeply at independent versus dependent in math and how to be able to identify them in a real world problem. So the top of this worksheet has some directions. They are written in italics, so make sure that you read them, but I'm going to read them for you here. It says for each set of variables, figure out which one is independent and which one is dependent. You're going to write I for independent and D for dependent. I have 2 of these examples done for you. There are still 3 available for you to work through. So the 2 that I did, the top one compares the number of minutes that you are running and the amount of calories that you burn, okay? So if we go running, right? We go running for a very short amount of time, 2-minute run, right? Here to the end of the corner and back, you're probably not going to burn very many calories. If you go run for 6 hours straight, you're probably going to burn a lot more calories. I don't recommend that, but you could do it. And that longer amount of time means more calories would be burned, okay? Remember I said time tends to be independent. The number of minutes that you are running would be independent here. The amount of calories burned depends on the number of minutes that you are running. That sentence is a very easy way for you to start looking at these type of problems to figure it out. I'm going to use the sentence the opposite way and we'll see how it sounds compared. The number of minutes running depends on the amount of calories you burn. So if my body decides to just start, you know, today we're going to burn a lot of calories, my brain goes, okay, we're going to go run a lot. That's not how these decisions work. That's not how our bodies work, okay? And you can hear that that sounds wrong. Let's take a look at another one. So it says, the second example I worked out is the amount of money that you earn compared to the number of yards that you mow. So say we're setting up a lawn mowing business, it's summer, you're trying to make a little extra spending money, okay? And we need to figure out which one is independent, which one is dependent. So let's try the sentence trick. The number of yards that I mow depends on the amount of money that I earn. Or the amount of money that I earn depends on the number of yards that I mow. Okay? This one can be a little tricky, okay? But people are going to pay you after you do the work. So you have to mow the yards before you can get the money, which means the amount of money that you earn depends on how many yards you're going to mow. And that's kind of the way it works in the real world. The amount of money you get to earn depends on how hard you, or how often and how many hours you put into your work. Okay, there are 3 more examples there for you. I would love to discuss these with you. If you're finding you're needing a little help getting through these, please feel free to give me a call, and I will gladly talk these through with you. Looking at the second section, it's going to make us go through and do the same thing, but a little more formally. It wants you to write that sentence. So example number 1, a wheelbarrow with several bricks will weigh more than a wheelbarrow with just a few bricks, okay? So we have a wheelbarrow with a lot of bricks and a wheelbarrow with very few bricks. Let's go ahead and take a look at this and see if we can't. Go ahead and clear my screen. Let's draw a picture, see if we can't make sense. So we all know I'm a beautiful, beautiful artist here. Here's my wheelbarrow. It's got some handles, got some wheels, right? So beautiful. And then here's my other wheelbarrow. Handles, get some wheels. Now, this wheelbarrow, let's have some red bricks. This wheelbarrow only has 2 bricks. This one has 6 bricks, right? 2 bricks versus 6 bricks. Now, does the weight of the wheelbarrow depend on the number of bricks, or does the number of bricks in the bucket, in the wheelbarrow, depend on its weight? Well, I know when I put more things on my wheelbarrow, when I put more bricks in there, it should get heavier. Do we go to our wheelbarrows if the number of bricks depends on the weight of the wheelbarrow? That means you walked over to your wheelbarrow and it said, you should make me weigh 70 pounds. And you went, cool, wheelbarrow, I'm gonna put some bricks in you so you equal 70 pounds. I really hope you're not talking to your wheelbarrows, because they're not gonna tell you what they want to weigh. That means that for this example, the weight of the wheelbarrow has to depend on the number of bricks that you put inside. Excuse me. So when you make that clarification there, your dependent variable is the weight of the wheelbarrow. It depends on the independent variable, which is the number of bricks, okay? There are a few more examples of that. You're talking about emergency workers in a car wreck. You're talking about temperature and time. You're talking about an expensive bill compared to the number of people you're paying for. There are a handful of those. There's one more on the back page, and then there's a new section. Okay, the other section is going to be some test prep. I know we're not doing state testing this year, but there are always going to be multiple choice questions, and so I wanted to make sure you got a little bit of practice on that. And the biggest thing for these is make sure that you are reading the question that they are asking you very carefully. So I did number 6 as an example with you. It says, a limo driver will charge an initial fee of $150 plus $3 per mile driven, okay? So the 2 things we're talking about here are the cost, how expensive our limo ride is going to be, and how long we're going to be in the limo, right? The number of miles that we are driving in this limo. It asks us, what is the independent variable? Our options are the initial fee, the total cost, the cost per mile, or the number of miles driven, okay? Let's ask our question. Does the cost of our limo ride depend on the number of miles that we drive? Or does the number of miles that we drive depend on the limo's cost, okay? Based on this situation, you would pay money, you'd take your ride, and then you would pay your initial fee, you'd take your ride, and then you would pay for the miles at the end. So if you can't pay for your miles first, that means that the cost is dependent on the miles. And if cost is dependent, then the number of miles we are driving is our independent variable. So your answer in that case would be the letter D. Okay, there are a couple more multiple choices like that. Read them carefully, do your best. The last one has you looking at a table, okay, which is very much how you would utilize these in the real world. Is you would track something. You would want to keep track of these things. You might make a table to track your data, and then to look at it and try to figure out what's going on. So I'll look at number 9 with you. I will not give it to you as an example here, but I will kind of start you off and help you start this discussion. The table below represents the relationship between the number of miles that Maggie runs and the number of calories that she burns. What is the independent variable? Okay. Does Maggie burn more calories when she runs more, or does Maggie run more when she burns more calories? I hope you are able to see which of these is independent here, okay? We're gonna move on in just a second. I'm gonna flip the page and I'm gonna set up for the last portion of this packet, and then we will check that out and I will send you guys this video, okay? Give me just 1 second. Right, so I got a whiteboard set up for us on the next screen. We are looking at the back page of your packet. There is 1 worked out for you. There are 3 more for you to do. This is the big assessment for this packet. It is graphically organized for you. It is kind of nice and neat and in a very similar setup to how the steps were done earlier. So hopefully you are better able to kind of walk your way through this and be successful, okay? You are selling tickets to your school's musical. Student tickets cost $2 and general admission tickets are $3. Basically what that means is if your school has a play and you, a student, wants to go, you usually get a cheaper price. General admission is anybody in the public. This would be moms and dads and brothers and sisters that want to come support their friend who is performing. So we're having a musical. Student tickets are $2. Everybody else is $3. You have sold 17 tickets and you've collected $42. We want to know how many of each type of ticket did we sell, okay? So we are going to define our variables here. Now, this one is a little tricky, so this is why I want to make sure to do it with you, because if we think about it, you're going to want to say that these variables we're figuring out is cost versus tickets. But we need to slow down. The question asks, how many of each type of ticket did you sell? So we want to know how many student tickets we sold and how many general admission tickets we sold. Those are our unknowns. Those are going to be our variables. So to define the variable, all you're doing is saying X is going to be, and in this case, X should be the number of student tickets. I apologize. My stylus is not writing as neatly as it should be right now. So that's the number of student tickets. Our Y value here is going to be the number of the general admission tickets. Okay? That looks, okay, it's going to be the number of general admission tickets. Okay, that's step 1. That's all you have to do is say X is going to be this, Y is going to be this. Step 2, we're going to come down, we're going to write our system, which means we're going to write equations based on the sentences in the problem using the variables we just established. Okay? So you sold 17 tickets. That means that the number of student tickets that you sold and the number of general admission tickets together is 17. You can write these sentences simply by going in the order of the words. The number, goodness, my apologies. The number of student tickets and the number of general admission tickets that you sold was 17. We're going to write a second equation that talks about the money now. To find the total value of the money you got for student tickets, we have to take the number of student tickets and multiply by the cost of that ticket. So the number of student tickets, as far as we know, is X. But the cost of a student ticket is $2. So we would say that the total number of money from the student tickets is 2x, $2 times the number of student tickets. And that total cost of GA tickets, we're going to write the same way. So that's our $3 cost times the Y number of GA tickets. Together equals, let's go back to the problem, you made $42. Okay? That is a simple way to set up our equations. Now, it is in standard form, which is okay. We are not graphing these. So don't worry about where the slope is right now. Don't focus on where your y-intercept is because we're worried about our algebra steps here, okay? Step 3 is to actually solve our system by substitution. So just like we substituted earlier in this lesson, we take something and plug it in. We are going to do the same type of thing here, okay? When you are solving these, there are going to be a couple of goals that we need to follow. First, I want to get a variable by itself. So I'm going to take this x plus y equals 17 here, and we're going to work on it really quickly. So x plus y equals 17, okay? Let's get y by itself. If I want y to stay here, I need to move x. I'm going to use my addition subtraction rule because that's a plus problem. So we will minus our x on both sides, just like we did in the last week to be able to write this as y equals mx plus b in our slope-intercept form. It's the same kind of process. So I'm going to move my x over. I'm left with y equals negative x plus that 17. Now that I have this equation, I can now be able to do the work to solve. So we're going to look at our 2x plus 3y equals 42. Okay? Now remember, y is actually equal to this. So anywhere there's a y, I can now put negative x plus 17 in. Okay? So I am now going to do that substitution. I've got 2x plus 3. We're going to put this inside parentheses here, make it easy on us. I have negative x plus 17. And we're going to put b equals 42 in there. Okay? And now, just like before, you're going to use PEMDAS to solve this. You are going to work through your order of operations. Again, this is worked out for you on your paper. We're going to follow these steps really fast to be able to break it down, okay? First step, we look inside parentheses. Can't do anything. There are no exponents. So we're looking for multiplying and dividing. Well, 2 times x, but we're kind of stuck there. This, however, is 3 times this quantity. So we're gonna go back and use our distributive property that we learned about a few weeks before, before the school's closed. So we're gonna distribute that. We're gonna pass it out to everybody. And you're going to get -3 times your x, because this -3x, and then 3 times 17, which is going to give you 51. So I've gotten that from the distribution here, and I'm going to bring down the rest of this problem. Okay. 2x minus 3x plus 51 equals 42. Okay. Remember, I like to draw my lines to help keep myself organized. I recommend that you do that. You show all of your steps on these. Show me everything. Okay. Now we're going to start simplifying this equation down. We're going to combine like terms. We are going to try to get that x all by itself. So looking at it, I have a 2x and a -3x. These are going to be our like terms first. 2 minus 3 will give me a -1. And when we combine, we do not change our variable. After that, I can go ahead and bring everything else down. Okay. I still need x by itself, so I need to get rid of that number that is tagging along with my x. So we're going to get rid of this 51. It is held on there with addition. So we use a subtraction to break it up. Minus 51. Sorry, ignore that. I didn't mean to put that there. Subtract our 51 on both sides. That side cancels out. 42 minus 51 does give us a -9 here. Okay, once we've done that, I'm going to bring down the rest of this. I have -1x. And now it equals -9. Okay, as you can see on your paper, and I know it's kind of squished now. I don't have too much room to write on here. But I had to get rid of the -1 in front of my x. Remember, it looks like a subtraction because you see the minus sign. But this is -1 times x. So you want to divide to break that up. Divide both sides by the -1. That side's going to cancel. You will be left with x equals negative divided by a negative gives us +9. Okay. We were able to figure out that x equals 9, which means the number of student tickets, here that you were able to sell is equal to 9. Let's make this red so it matches the colors we used in the beginning. So x equals 9. Okay. The last step, we're almost the very last step. The last step in solving is you need to go back and figure out what y is. Okay. So I already can look and pretty easily tell, right? X plus y equals 17. X plus y, so if we look over here, x plus y equals 17. So 9 plus y equals 17. -9, -9. Y equals 8. Okay? Once you've figured out one variable, you go back and plug it in to solve for another variable. This is all a lot of steps, and I know that it can feel overwhelming. Make sure that you show your work neatly and carefully. Use another sheet of paper if you need to, but please make sure you show all of your steps because it is so easy to get confused. And it can be hard to figure out where you may have made a mistake if you don't have those steps to follow. So all the work that you see me doing is so I can do the work right, okay? This is not something I'm just telling you to do. To do, it will help you. Step 4 is to now put our math into words. So I got x equals 9 and y equals 8, but we need to talk about what that means in our problem. So we're selling tickets to the school play. You sold 17 of them, you made $42, and we wanted to know how many student tickets and how many general admission tickets we sold. So We're gonna write a sentence. I want you to write a complete sentence, okay? So this person, we can say they sold, and X equals 9, so they sold 9 student tickets. Okay? And they sold 8 of the general admission tickets. That's it. That's what we're doing. Remember, if you need help on this, please let me know. I am more than willing to talk it through with you because this is very, very important to the rest of your career in math. And this is the kind of thinking that you are going to need to do when you are in the real world, okay? This type of math using linear equations like this are useful for, yes, silly little things like figuring out what kinds of, you know, who sold what kind of how many tickets and things like that. But we also utilize these to do comparisons. If you are trying to figure out which cell phone plan is better, this is something I actually did recently. I had to compare T-Mobile to Verizon. And I had to see, okay, so this one's more expensive right now, but the payments are different. And so you would utilize these types of equations in this type of scenario to figure out when you're going to get the better deal on that phone plan. There are a lot of other very great examples like this, but things like cost-benefit analysis are where we utilize them a lot in the real world. I hope you guys are doing well. I miss having you. I miss seeing you. I wish we were back in our classroom, but I am proud of all the hard work that I'm seeing coming out of all of you. You are really stepping things up in this strange, strange time. Please let me know if there's anything that I can do to help make this any easier. Remember, there are online additional Math Excel assignments, and all of those Help Me Solve This in View and examples that you can access. They are considered extra credit assignments. You will earn extra points and bonus points if you complete them. So if you're a little on the fence about your grade, you can bring it up if you want to complete any old, missing, or new assignments, all right? It is good get to reach out to you guys. Please make sure you contact me if you need me. Have a great day.